So let's go back to what we were doing before. So first of all, if you have two sets, so sets where you have two sets A and B, then we either have A intersection with B is an empty set, or A intersection with B is not the empty set. So sometimes when we have the empty set, then that captures information that are dislinked from each other. So we could use this to divide a space up into a bunch of like different sets of points, all right? Or different set of structures. Like for instance, what I described before with Z, all right? So let's write the following corollary. Corollary 2.4. Two congruent classes modulo n are either disjoint or identical. So let's prove this. So proof. So first of all, assume you have two disjoint classes. So assume that things are not disjoint and you want to show that they are identical, all right? Assume that you have A and C, which are disjoint. Then what it means that if they are disjoint, it follows that there exists a B inside of their intersection. There exists a B inside of the intersection of A intersection with C. So therefore B is congruent to A mod n, and B is congruent to C mod n. Then it follows that by symmetry we have that A is congruent to B mod n, and B is congruent to C mod n. So hence A is congruent to C mod n. So by the previous and by the previous result, we have that the class of A is equal to the class of C, and we're done. Alright, so in the next video I will do the last corollary of this subchapter and we'll continue off from there. See you everyone, bye.